I just must not hit record. Okay, well, I spent the last like 15 minutes explaining stuff. Yeah, what can we do? How can we change this class? Sorry, this interface. We can make it an abstract class. We can say, let's go public abstract class, charging strategy. And now we have to deal with this stuff. We'll just make this abstract and make this abstract as well. But then we can say, well, maybe we have a private string payee and a private list members. Now this is kind of awkward because then, you know, we've got payee and members here, and then we've got it in the restaurant as well. So, okay, maybe that's not what we want. Maybe we just want to store the restaurant. And so we have this bidirectional relationship where the restaurant stores the strategy, but the strategy also knows about the restaurant and can access it. That's perfectly valid. This sort of thing called bidirectional coupling, not sort of ideal, because then if you change one thing, then you have to change the other, and that creates more coupling, right? But sometimes you just need it because you need one to have access to the other, and you need the other to have access to its counterpart. So we'll say private restaurant. I don't know how to spell restaurant. Restaurant. Here we go. So import it, and then we're going to say public charging strategy, and that will take in just a restaurant and say this dot blah equals r. Okay, that seems good. So then we can say in our restaurant, we'll change that in a second. We can pass in this. What's wrong with that? Cannot convert to, Oh, what? Oh, maybe I haven't implemented it properly. Oh, it's not, the implementation hasn't worked because we haven't, yeah, I think, no, it's like, this is fine. It's because this isn't working. And so this hasn't actually been implemented yet. And so it's saying, well, you don't actually implement this interface. We do need to change this though, because now we can't instantiate this. I mean, we never could before. So we make it just to say a standard strategy, standard charge. Cannot convert from standard charge to charging strategy. What are you talking about? Oh, I know what's wrong. Say extends. There we go. What's this? Constructor. And so this is the thing about any sort of refactoring is you just got to go and kind of clean up any mess like this. And it sometimes just takes a bit of time. Nope. Extends. Yep. So that'll do everything we need to, and we'll pass in this. Now, okay, members. What we'll say is we'll have r dot, or how do we do this? All right, we need to say get restaurant members, get payee. So now these are just methods, and what we're going to do is we're going to implement them in the superclass. We'll say public list string get restaurant members, and then we're going to return r restaurant dot get members, which doesn't exist. We could do this like with a double getter call. That would, it's not great style, so we'll just wrap it. So public list string get restaurant members. I wish we had an exercise that didn't take so long to write. Like restaurant takes ages, members. Okay, that's good. Get members. Oh, sure. Cool. No red lines. All right, now we need this payee. So public string get payee So return restaurant dot. And now we have this kind of awkward thing where the payee is passed into the function. So maybe we need to, But we do have this thing called payee is member actually. So maybe we can actually just get rid of this and say payee is member. And we can do the same thing in, what is it, happy hour. And so now we don't even need to pass around the members. That was pretty convenient. This will be a double. So we kind of do all that refactoring maybe for nothing, but that's okay. So we'll get rid of that. We can probably get rid of this as well. We could have probably just made it an interface, but we'll keep it that way for now. Again, lots of these sort of design problems are just trying stuff out, see what works. Then you realize that you had everything you needed all along, and it didn't matter. So now we're just going to say return charging strategy dot get cost dot cost. There we go. Order, and then we'll say members dot contains payee. And then for this one, we're just going to say double modifier equals charging strategy dot get dot modifier, standard charge modifier. Now this doesn't like it. Why is that? Holiday charge needs constructor. Cool. Are there any questions? That was a lot of just writing code. Oh, I see what you mean. Sorry. Good. Where my charge is gone. No, because you like recursive call is only when the function calls itself. But this having bidirectional coupling just means I know about you, you know about me. And I can talk to you and say, call this method. And you can talk to me and say, call this method. Like before we said, restaurant in the charging strategy, we said restaurant dot, get something. And then in the restaurant, we say charging strategy dot cost, which now doesn't work. Cannot switch on a value of type charging strategy, only convert. What? Okay, never mind. Cool. That's all fine. Does that make sense? So it's like a recursive call is, like your factorial function was called factorial n minus 1 in the factorial function. We're not doing that here. We're just having two pointers. It's like we have a struct, right? Two structs, struct A and struct B. Here's A, and here's B. And they both contain one thing, a pointer. And the pointer, all it does is point to the other struct. It's basically that. So you could say struct A pointer, I don't know how to do pointers, pointer, and this whole thing would just be A again. It's kind of like sort of, like those math proofs where it's like you get the original result again after you do a certain number of steps, kind of like that. But it doesn't really, and it doesn't cause any problems. Like this sort of bidirectional coupling happens all the time. Okay. Oh my god, we have 15 minutes to do 2 patterns. We're gonna have to go for a bit longer, and I need to charge at some point because I must have not taken it to work. So, are there any questions about the strategy pattern? Yeah, Dave. Yeah, so if I was doing this again, I would abstract all this stuff, and I would just have some sort of, because see, the problem is, I think if we go to the ones where it's like the modifier is slightly different, but then the modifiers here as well this is where this is a requirement where it's like if you're a member, then you get a even more of a discounted happy hour than here. So I'd probably just have something that's like figuring out if a pay is a member and then returning this number. The problem with these sorts of like really simple example. I mean, this isn't simple, right? It's taking us 30 minutes to go through, but it's like it's hard to put a whole lot of functionality in, and it's more just to illustrate the idea. But yeah, I would change this whole screen crap because it's just more repeat code. Are there any other good questions? Cool. Let's see how long my computer can last for. Okay, this is not doing well. I'm going to grab a charger. We'll take a short break, and then we're going to come back. We're going to have to go over time. Just I want to talk about observe. I want to talk about state. We'll do those nice and quickly. So yeah, we'll take a break now and then go till probably like 20 past. So that's okay with everyone. Yep. Awesome. I'll be right back. Share screen. Share desktop 1. And here we are. All right, so the observer pattern, we're going to look at YouTube as an example. And we have nothing at the moment. And so this one is like, and another way you could talk about the observer pattern is like a sort of subscriber and producer model. And it's the same thing with YouTube, right? Like if you subscribe to someone's YouTube channel, whenever they post a new video, you get notified. And that is the foundation of the observer pattern. And we see it everywhere. It's so common. So in here, like you have a producer, which has a blah, 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 blah. I don't care too much. But here's the key thing. When a producer posts a new video, all of the subscribers are notified that a new video is posted. So let's try and code that up now very quickly. We're not going to do tests. We don't have time. We're going to make a new file called producer.java. And then we'll have a one here that's called like a user.java. So this is like, you know, some YouTube producer that produces videos. And this is some user that subscribes to videos. So what does they have? A name, a series of subscribers, and then videos. They'll just be strings. So private string name. Am I recording this one or have I forgotten that again? No, I'm recording this one. Private list user subscribers and private list string video. And we'll have a constructor, or actually we won't even, we'll have a constructor that just says the name. And then we'll have a function which allows us to add a subscriber. And this is what we call attaching an observer to a thing that's observed. So we'll say public void attach user, and all we just do is add it to the list of subscribers. And then what we'll do is say public void post new video. And this is the change in state. This is when someone goes bang, and then you have to react to that. Or I should say more accurately, this producer is the thing that goes bang in the game, or the thing is like your, like when your phone sends you a push notification, you receive the notification, right? So this is doing the pushing. And what we're going to do is say, okay, well, we've posted a new video. So we'll say string video, videos.add. And then we're going to say subscribers. We'll do this nice and functionally, .for each. This is the same as just doing like a for loop. And then we're going to run a little anonymous function, like we learned about last week, which doesn't like me for some reason. Oh, we need to take in subscriber. And then we're going to say for each subscriber, subscriber dot something. Let's do that. So in user, all we need to have here is a method that says public, what do we call this? Public void update. And that just takes in video name. And this is just going to print out new video was published. And this is like, you getting an email, some sort of notification that someone has posted a new video. And in reality, more complex systems, this handler, this thing that receives the processing of this change in state of this event happening, will do something in the background. Like in the case of a button being pressed, it will, launch the Zoom meeting, right? The Zoom website that we were on before. So we have this update method, and then we say for each subscriber, we say subscriber.update video name or video. Cool. I'm not even going to run that because the code's quite simple, but this makes sense for everyone. Does anyone have any questions? So there's two ways to implement main ways to implement the observer pattern in terms of you've got these producers or these you have these things that produce events or things that are being observed, and then you have the observers. Sorry, the subject, that's the word I was looking for. And this is like the subject because you're sort of constantly looking at this producer and going, okay, when they're producing a video, then an event happens and it lets all the subscribers know. But there's multiple ways that can be implemented. So if you think about like this way is you have the producer and then they go and notify all of the subscribers. This is not how it actually works, it would be something different, but the principle is the same. Whereas maybe another way, like I used to do Army cadets and we'd have these things called observation posts where you sort of stake out that enemy, like a fictional scenario. And what you'd have is an observer pattern where here's like the thing you're observing, subject, right? And you have your observation post over here and you make it in lots of bushes and stuff. And you'd be watching the target, just like some people doing some stuff. And maybe when they get in a vehicle and go and drive off, then okay, we say, okay, we notify the headquarters or whatever. And this is what we call a pull observer pattern, where rather than the people notify us, is we pull events by watching them in this case. This is just like a real life example, but it's the same idea where the observer pulls the event from the thing that's being observed or subject and then causes a change in state rather than, these people go and notify the observer like we've done here. That's something to take note of. Are there any questions? I'm going to do state pattern very quickly. Okay, I hope we can do it very quickly. We might even just do the concept and not the implementation. Cool. Okay, so state pattern, we're still at YouTube and users can view a video. A video now has to be a class, which is fantastic. And a viewing has a series of states. It can be either locked, playing, or ready. And we have all these kind of transitions. Let's just code it up and see how far we get. We might not get to all the states, but let's just do playing and ready to start with. So now we're going to turn this thing, string video, we'll say new video. And this will be a list of videos. And we'll make a class called video.java. Cool. And then that is fine. Why isn't this working? The constructor video string is undefined. Yep, that's okay. Public video. Oh, string name. So video name equals. Cool. All right. Now we're going to have this state. Do you guys remember state diagrams from 1531? Maybe a little bit, roughly. So there's this big idea in computer science about these state machines. And we talked about the strategy pattern before, and strategy and state are kind of sibling patterns where the main difference is strategy is you can chop and change between strategies as many times as you like and at any time you like. You can say, okay, we're doing the happy hour strategy now. And now we're going to go to discount. Now we're going to go to happy hour. Now we're going to go to whatever we were before. And you don't have to move to a particular strategy, there might be certain conditions on which you move strategies. But if there, as you get more conditions and more, it's like, well, you know, I don't even have a whiteboard on today. You know, you have to go from this strategy to this one, and there's certain kind of steps involved, and you start to get this sort of like a state diagram. Then it turns into a state pattern. In fact, as soon as you start to impose these conditions where it's like, well, if you're playing and I press the play button and then I go to pause, and then I press the lock button and I go to lock, and I press the play button again, I go back to pause. These are these different states, and what you have is states and transitions between states. And that's illustrated in the state table here. So a good idea is to just think about a few examples. Think about the examples we'll give you in this Tute and the labs and stuff and the lectures, and go, okay, you know, what are the states and transitions for the strategy pattern? What are the different strategies? How do we dynamically change between strategies? So for this one, we're going to do the same thing here where we have a subfolder called state, and we'll have a super state called playing state.java, and we'll make this just an interface for now. And so you can look at the actions by saying, well, locking, playing, and next. These are our three different actions. And these columns will comprise methods in our interface. I'm going to get rid of this. So it's a public void play, public void lock, and public void next. Okay, and then we'll go, oh, this is probably a bad one. We'll call this player state, because playing state is an actual implementation of the state. So we have this playing state.java, which will implement player state. Cool, and now we get sort of prototypes of these three methods that we can just fill in based on the table. So if we lock it, then we stop playing and switch to lock state. Okay. Now we need a way to say, we're going to have this thing again where we link, the state links back to the player or the video. Yeah, sure. We'll do this in the video class. So we'll say private, what is it? Player state. I've kind of messed around with semantics here because a video and a playing of that video are two separate things, right? Like the video is one thing and then you play the videos. They're sort of two different things semantically. But we're just going to combine it here for the sake of saving time. And so what we'll do is store a reference. So we store a reference to the state in the video, like we did with the strategy in the restaurant. And then we'll store a reference to, can we do that? We might need to make this an abstract class, actually. Let's make this an abstract class. And we'll have a private video. And again, we need a constructor. All right, and then we need a getter as well. So if I can just auto-generate that, source action, generate getters and setters. Cool, okay, that's done. So now I can say in my playing state, get video, oh, hang on, sorry, let's go back here. If playing stops playing and switches to lock state. All right, so what's going on here? Player state cannot be a super interface. Oh, sure, extends. Now we have the same problem we had before. Yeah. So we'll say get video dot set state new locked state. And so now we have this transition going on. We haven't actually implemented some of these yet, so we'll do the set state first in video and say public void set state, and then we'll take in what the new state is going to be and just do it like a normal setup. And now we need to make the lock state class, which will also extends player state. I think I need to, in the abstract class, say abstract. Oops. Okay, and now I'll have to implement those in the subclass. Cool, all right. Now the code's compiling, maybe. We have one more problem. The constructor lock state is undefined. I think we just need to pass in get video. Cool. Woohoo, we did one cell on the table. So now, if you hit play, oh no, sorry, this should go in the lock method. If you hit lock when you're playing, it'll transition to the lock state. Let's do a couple more. I think you probably get the idea though. If you are playing and then pause the video, we go into ready, which is like, paused. So we'll make a ready state. Java. And this will implement player state, sorry, extends. Okay, again, we get our three methods, play, pause, lock. We need a constructor. And now we can say, pause this video. So there's no conditions around it. But when we look at the other rows in the table, we'll see that it won't just be like you call lock and then you immediately transition state. There'll be something in between that happens. There might be a conditional. So here we'll just say get video. I don't really like this, by the way. This is almost like a use case for when you want to use protected. So then you can just say video.getState rather than just like having to use the get every time. But it's okay. New ready state, get video. That's cool. And then lastly, if we hit next, it starts playing the next video. Okay. I'm not going to do that because it would involve going and figuring out what the next video is, and we haven't really mentioned that. So we'll just leave it blank for now. Okay, so we go to the lock state now and fill out the rest of the table. So if we are locked and we hit the lock button, if we're playing, switch to ready state. What? That's weird. If playing, switch to ready state. Playing, switch to... I don't know why this says... I don't know what this is trying to say here. So let's skip over that. If playing, what does that mean though? We're locked. Okay. So if we hit play, say if video.playing, I'm just going to make this up where we have a boolean, which is like private is playing, and then we'll have a setter for that. Where are we? Lock state. Then we will get video dot set state. What are we ready state? Otherwise, nothing happens. And again, it's like all this get video. I don't really like it that much, and we could think about how to make this design a bit better. So if we're in the ready state, okay, if we're playing, then we just switch to the ready state automatically. Sorry, this goes in lock, and then this goes in play. And then if we hit next, we just say system.out error locked. All right, let's do. We did that, we did that, we did that. Okay, let's do the ready state now. Again, this is all quite sort of simple in that there's not a whole lot of logic here, but that's just because it kind of takes a while to explain or to set up the different states and the transitions. But normally you'd have lots of stuff going on in each of these. There's, maybe 10, 15 lines of logic to say, if this happens in transition to this state and perform this calculation and do this certain thing. So we're going to lock state here. And then if we are in ready and then play, we'll say get video dot set playing true. I would normally have that just be set playing and not passing true, like you just turn on the boolean by default. If next returns error locked. There we go. And that is our state pattern. Are there any questions? Cool. So just to kind of consolidate, 3 patterns we talked about today, and the key ideas for each one. Oh, this is what's the key ideas to the strategy pattern? Anyone? Okay, key ideas. You have dynamic changing of strategies. You can say, I want to go happy hour, normal state, normal strategy, discount, whatever. You can change on the fly. Dynamic changing. And there's generally not many conditions around changing, so you can change to any strategy from any other strategy. No conditions. And then you have functionality like this cost method, which is sort of polymorphized across the different strategies to extract some sort of functionality. Okay, all right, state pattern. Oh, sorry, and when you're doing the strategy pattern, you need to identify what the different strategies are and what the functionality is. So for state, what are the key ideas? We just talked about them. Anyone, or you're all asleep? We have states, and then we have transitions between those states, and there'll often be logic around the transitions. Like go to the state if this happens, go to the state if this happens, and you could draw like a state diagram from it. You want to identify your states and transitions, or your actions, like locking, playing, or hitting next. And then for observer, what are the key ideas there? Yep. Yep. Listening for events or listening to some sort of state change. And then on the side of the, depending on how to implement it, there'll be some sort of handling, there'll be some sort of, once I click this button, run this function, some sort of handler. And then what are the 2 ways we can implement observers? Push and pull. Okay. So we can either push out notifications or we can pull notifications. Like the observation post. Cool. That's all right. Any other final questions? No, let's go to the lab and talk about the project and hopefully wake up a bit.